Let's do section 11.2, page 552, exercise 35, which reads, a particle moves in the plane with position vector cosine 3t, comma sine 2t. Find the velocity and acceleration vectors and determine the path of the particle. So we know that r of t is going to be equal to cosine 3t for its x component, comma sine 2t for its y component. And we know that v of t is going to be the derivative of r of t, and that the acceleration vector is going to be the derivative of the velocity vector. And we also know that the x and y directions are separate and independent and don't affect each other. And this means that we can take the derivatives of each component separately, and we can do that term by term. So let's start by taking the derivative of the position vector so that we can get the velocity. So when we take the derivative of the third term, we're going to get negative 3, not cosine, but sine 3t, comma 2 cosine 2t. And that's going to give me my velocity vector. And now, to find my acceleration vector, I'm going to take the derivative of this term by term. So this is going to give me negative 9 cosine 3t, comma, negative 4 sine 2t. And that will give us our acceleration vector. And then the final thing that we're supposed to do is determine the path of the particle, which basically means that we want to graph the position vector as a function of time. And to do that, we're going to have to use our parametric mode on our calculator. And there is a separate tutorial to help you figure out how to do that. And so we're going to plug in, just so that you know, this is what we're going to put in for x1, and this is what we're going to put in for y1. And I let my t values go from, I think, about 0 to 7. Gave me the whole pattern. So I'm going to give myself a little more space here. And then here are my axes, x and y. And my graph starts over here, and it goes up like this, and down through the origin, and back up almost like an S. Kind of more up like this so that it straightens out, back through the origin, and back swooping up like that. So it traces this way. And comes back to where it starts.